Okay, so this is the part, the STL file that you um, sent to us. Does that look
That
about
looks like
right?
it. Yep, that looks about right.
Okay.
And my main question is this possible?
Oh yeah, actually it's gonna be pretty
Okay.
easy.
Oh, wow. Okay.
Yep.
Yeah, I
Um,
tried. I tried it in Cabinet Vision, and I wasn't getting very far with it.
okay, well we'll just show you the quick way to do it. Then obviously you can get into more detail and you know, as far as surface finish and things like that. But let's go.
Yeah.
I'll just show you. I'll just go through the general approach, which is basically the same for every RhinoCAM part. So
Okay.
basically, we open the part and look at it and see basically how it's oriented. And
Hmm.
if you look at the world origin here in Rhino, you see that the Z is pointing up.
Yeah.
Okay, so that tells us that it's not in the right orientation
Right. Okay.
for machining. So well, let's go ahead and run the milling plugin. So this is RhinoCAM 2019 on Rhino
Hmm.
6, and we're going to run the mill module. So what you see over here on the left is the milling browser. Have you ran the demo at all?
I have not. I was starting to do that
Okay.
earlier when I called Kelly
Okay.
to ask her about the post processor. So.
Okay. So this is the machining browser on the left. You have the machining browser, the main machining browser at the top, and then you have the machining objects browser down here at the bottom. So
Hmm.
the first thing we're going to do is you initially do it like a mental checklist when you first open the part. Uh, is it in the right orientation? What are the units? We're in inches. And is that correct? It's an inch part?
Yes.
Okay. And we know from the geometry that it's a mesh.
Hmm.
And uh, for the orientation, we see that it's not in the correct orientation. So
Right.
RhinoCAM has a real easy tool to orient your part for machining. So if you go at the top, you see it's got a program tab and a simulate tab. On the
Hmm.
program tab, we're going to be moving from left to right. Excuse me just
Hmm.
one second. Phone,
Oh, no worries.
turn the volume down a little bit. So what we're going to do is in the setup menu, we're going to just pick the orient part command. And that, just excuse those little pop-up dialogues. This is the development computer, so it
Uh-huh. Okay.
pops those up. So I apologize for that.
No
So
worries.
so what we see here is we want to orient it so you can machine from one of these directions, either this face or this face in the back. Since it's
Hmm.
symmetrical, then I assume you want to machine one face and turn it over and machine the other.
Exactly. Or I was going to do 2 3/4 inch sheets and glue them together.
Okay. Okay. Well, we can show it both ways.
Okay.
That's just a matter of stock size. So
Uh,
we'll
yeah.
go ahead. Did you have a question?
Well, I was going to say we could glue up 2 sheets, and it would be easier to do a two-sided milling
Right. Right.
if that's
Right.
possible.
Yeah, that's
So
possible.
yeah,
Yeah, that's
cool.
possible in the standard configuration. Now, one thing about the standard configuration, you're going to machine one orientation at a time in,
Hmm.
in one part. But since your part is completely symmetrical, you can just turn it over and run the same program.
Yeah. Okay.
So let's go ahead and we're going to align it with this front face, and we'll pick OK, and then we'll do a zoom all. So we see that it flipped it over with this top face aligned in the Z-axis, and that's what we want.
Perfect.
So now what we're going to do is we're going to work our way from left to right, and we're going to set up the machine, and we'll set this to a 3-axis. All 2 and 3-axis parts we should set to 3-axis.
No, I can't. Hold on 1 second.
Sure,
I'm on
no problem.
Okay, sorry. Okay.
I'm sorry.
Hello?
You still there?
Oh, I'm
Yeah.
sorry. Yeah, I'm here. Thank you. Sorry.
Oh, that's okay. So for both 2 and 3-axis, now this will require 3-axis because you have a fillet here. So we're going to
Yeah.
set this to 3-axis and pick OK. And then we're going to set the post. What is the controller type on your machine?
Hi, yes, I'm here.
Good. Can you hear me all right?
Yes, I can hear you perfectly. Okay,
Good. Good.
back in business.
Okay. So now where was that? We're at the
Okay,
post processor. So what
yeah.
I was asking you was what uh, type of controller do you have on your CNC machine? Is it a Mach 3? Is it a, what is it? Do you know?
A controller. I don't. So we have an
Oh, we can,
Omnitech,
Omnitech. Da, 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 da,
Omnitech
da.
Selects
Okay.
controller.
I don't see
I'm
an
not
Omnitech
sure.
on here. What we can do is we have a built-in post-process generator. So
Uh,
as long as your controller, as long as your controller accepts standard G code, ISO G code,
yeah.
we can make one of these posts work. Uh,
Okay.
so basically, to create a new post, we just ask you for some G code samples from your manual, the controller manual, and
Mhm.
we will select a post and create one for you. So let's go ahead and we'll just select. Let's see, we'll just select the Mach 3 for now, inch. Pick OK there. So we see we got the machine set to 3-axis, we have the post set, and
Mhm.
now we're going to go ahead and define your stock. So we're going to set up a box stock,
Mhm.
and first thing we'll do, we're going to copy the model bounding box. So that's going to tell us the length and width of your part. So it's 21
Okay.
and a half by 21 and a half by 1.5.
Yeah.
Now, how big in the length and width would you like the stock? Now, you need to take into account how you're going to hold this down. If you're going to flip it over, you might want to have the stock a little bit larger, so you maybe put some screw holes in the corners to line it
Yeah.
up, and then just flip it over and then line it up. So
Yeah.
let's see what 26 by 26 looks like.
Okay.
I took a look at it real quick, and 24 by 24 is going to be a little bit tight in the corners, so
Mhm.
we're gonna up it to 26 to see what that
Perfect.
looks like. And the next step was we're going to align the stock with the part.
Mhm. Mhm.
And right now the stock is 1.5 thick. So it really, the Z alignment doesn't matter whether it's center, top, or bottom, because it's going to be right in the
Mhm.
middle.
Yeah.
But for the X and the Y, we're going to put it right in the middle and pick OK.
Okay.
So there you see that that's the stock size, and that leaves you a good amount of room to put some mounting holes in the corner here.
Yeah. Okay.
Okay. And what we're going to do now is we're going to set the material. Obviously, it's probably going to be wood, I imagine.
Yeah, like a MDF.
Okay. And then also you can turn a texture on in the wood, in the material, if you like to see that.
Mhm.
For practical purposes, I just leave the texture off for now.
Yeah.
Now,
Okay.
we got to think about the quickest way to machine this. In RhinoCAM, what's really cool is that you can control your machining regions just by drawing simple curves, okay? So we don't need necessarily any of the mesh geometry to control the X and the Y of the tool. It's obviously going to control the Z depth, okay? And
Mhm.
the tool is going to pass on the part, but we want it to go a little bit past the part, okay?
Mhm.
So what we're going to do is we're going to just do some simple Rhino commands, and we're going to create just a simple rectangle. And let's
Okay.
go over here and make sure our mesh wires are on and make sure we're set to mesh. And we're going to select from this corner, and we're just going to go over to this corner. So we have a rectangle there, okay? And
Mhm.
now we want to contain, we're going to offset that rectangle to contain the toolpath into a square area. So let's just do a simple offset command. And my default offset is 3/8 of an inch. That should be fine.
Okay.
So let's go ahead and offset that. So you'll see now in the top view that we have a rectangle here around it.
Cool.
Now, that 3/8 inch offset, that's just assuming that you're going to rough it out, say with a 1/2 inch bit. If
Yeah.
this offset needs to be wide enough just so your tool, your cutter can get in there, If you're going to use a larger cutter to like for roughing, you want to have the offset distance at least the diameter of the cutter, right?
Right.
So for now, for practical purposes, I just made it 3/8 of an inch for now. So let's go to our isometric view here. So that's all we need to do as far as for setup for this part. So now we'll go ahead, if you want to, you can create a work zero. In other words, where you're going to zero the machine at on. We'll show you the highest Z, say to this corner right here. It can be in any corner or any point. For practical purposes, I'm going to set it to one of the corners.
Okay.
So now we have a work zero. This is where you're going to, when you set up the stock on your machine, that's where you're going to zero the machine out on.
Yeah. Okay.
So now we're just going to go straight in and we're going to create a 3-axis horizontal roughing tool path. And to contain this machining area, we're just going to select, pick the select curve edge regions. We're going to pick this rectangle we created, and that's the area that we're going to machine.
Okay.
And for a tool, the tool tab, we'll go ahead and create a tool. And
okay, and this is what I would do. So none of my tools are entered. I don't have any of my tools entered in, and this is where I would enter in my tools that I have. Okay.
What would you like to rough it with?
Let's say half inch flat mill too big, you think?
Too what?
Too big of a diameter?
No, half inch will fit right in there. Okay.
Yeah, okay.
For tool length, it's 2.5 inch flute length, so that's plenty deep. You can when you set your tools up, obviously you're going to put in the tool, proper dimensions, the tool length, flute length, shoulder length, etc. And the holder diameter and the holder length, that comes into play if you're doing if you have any collisions like on the stock in the tool. But we'll leave these set to the default dimensions except for the tool diameter. That's set to a 1/2 inch. Okay. And are your tools high-speed steel or carbide or ceramic? Do you know?
Carbide.
Okay. And for the feeds and speeds, do you know how fast you want to cut this? Do you have?
I don't know it off the top of my head. I actually just ordered a bit that's a 2-inch cutting edge length with a 1/2 inch diameter, and I haven't entered all of the speeds yet.
Okay, so we'll use the we'll go ahead and use the feeds that are in the default, but you can set those up and assign them to each tool. Okay, so let's save this tool. We'll call it flat mill. We'll call it flat mill -0.5 diameter. Okay, and we'll save this as a new tool, and then we'll pick OK. And you'll see that your tool was listed down here and also on your tools tab up here. So we're going to use that tool.
Where did you go to enter that tool?
You pick the create edit select tool.
Okay.
Yep.
Yeah.
And now you can also do that from here on this tool tab here.
Okay. Yeah. I see.
But you can do it in the middle of an operation or outside of an operation.
Cool.
So the feeds and speeds, we're going to load those from the tool. So those are the speeds and speeds that we had set when we created the tool. And you can change them here if you like. Now to the clearance, this is where the tool is going to retract to when it transfers. So by default, it automatically calculates a height. If you look at it, you see there's a height there that's automatically calculated. And you can set that to whatever you want. Okay? Okay. And for our cut parameters, this is a roughing operation. So we're going to leave this set to 10 thousandths for tolerance. And because we're going to come back and we're going to finish it. And we'll leave a stock of 25 thousandths. And here you can set your cut cut pattern. You have different cut patterns, linear, spiral, radial, high speed. For now, we'll just do a offset cut pattern, and you can set the cut direction, where to start, whether on the inside or the outside. We can probably be best to start on the outside since we know we don't have any material, any part material in the corners. And you have all these different parameters you can set. You can automatically do a cleanup pass, or you can automatically keep the tool down. And for the core facing areas, these are the areas that inside here where you see these stick up above the rest. So that would be considered a core area. And you can set that to an island offset or a linear. Now, island offset means it's just going to go around it. Okay. And you can set the step over. And for the cut levels, now, if you're going to cut this on two sides, obviously you only want to go down halfway.
Right.
Okay. So we know that the thickness is 1.5 inches, and we know that the bottom will be negative 0.75. Okay.
Okay. And that's halfway through.
Yeah, you see the plane there is displayed on the part.
Yeah.
Okay. So we got a 1/2 inch cut level maximum. And for our engage and retract, you have different options for engaging the cutter into the material. You can ramp in on a path motion. You can do a helical motion, or you can do a just a straight linear motion, and it'll zigzag until it gets into the part. What would be your preferred method to enter?
I would say path, slipping in.
And then you can, for the path, you can set the height and the angle, and we'll leave those set for that for now, and you can adjust those, obviously. And these linear extensions would come into play if we didn't have a containment. Since we have a containment, you're not going to really see those come into play here. So let's go into the cut parameters tab. You can automatically fit arcs to your tool paths. And we'll set an arc fitting tolerance to 0.02, which the preferred tolerance is twice your cut tolerance. So this is a 10,000. So we're going to make this 20,000s. And let's go ahead and just generate this and see what we got. So it's calculating all of the part in this containment area, and this is what it found.
Oh, wow.
So
it does that automatically.
Yep.
It you set your containment area, and it automatically finds all that. It
figures it out for you.
That's crazy.
As long as you have a mesh or a surface. It wouldn't do that with just curves.
Yeah.
Okay, if you had just curves, then you would have to select the curves, and you would have to control the depths and everything. But since you already have a mesh, it already knows where to go and where the part is and where the stock is. And then
the mesh
also
automatically comes in from the STL file from SketchUp.
Yep.
Correct? Oh wow. Okay. Cool.
And you see that we were contained, so we got good coverage around the corners and everything. So let's go ahead and run a quick simulation of this. And we'll just turn toolpath off. And you don't have to sit and watch it all. For the demo, I did, but you could hit the pause and go directly to the end. So here's our roughing operation based on a 1/2 inch tool, and it was, I believe, it was a 50% step down. So that's a 1/4 inch step down. And the step over, let's go ahead and take a look at that and review that again. So it was a 25% step over, so that would be 1/8 of an inch step over.
Right.
And the step down was 50%, so that would be a 1/4 of an inch step down. Now you can adjust these if you want to have a finer step down or a finer step over. Okay, so there's your roughing. Simple as that.
Cool.
Now the finishing is going to be really even easier, because what we're going to do is we're going to map a parallel finishing toolpath right across this mesh. Now, one thing you might want to consider is when you turn this over, let's just turn it over, look at it. You'll see that it's cut down, okay, 3/4 of an inch, okay? Now, when you do this other side, it's going to cut down to 3/4 of an inch, and then your part's going to not have any containment. Your stock is actually going to be sitting there, and it's not going to be hard
Yeah.
mounted to your holes, all right?
Right.
So there's different ways you can handle that. You can you can not cut all the way down. Say you can cut maybe down to a 1/16 of an inch away from the middle, okay? Or you can model just some square blocks that go all the way through the part from each side.
Yeah.
And we can do that real quick, and I'll show you how to do that if you would like to do that. Let's do this here, and let's make sure that we see everything here. Okay. Now, when you do this, you can do it in more precise locations. I'm going to show you basically how it's done.
Okay.
So basically, you just want to run a solid or a surface through here that passes through the part and through the stock. So that when you do your finishing operation or your roughing operation, it sees that part and it'll go over it. So it'll leave you a tab there. You follow me?
Yep.
So we're going to just do a real easy box, and we'll turn our vertex off so we don't pick any of those, and we'll
That was from the solid tab?
Yep, from the solid tab. Okay. And we're just going to put a little, let's move over a little bit and put one, say right here. And you see that it's right in the middle of your depths here. So we want half on one side and half on the other, okay?
Right.
So now you'll see that it just created a solid starting over here at the 0, 0, but that's fine. We'll just, it doesn't matter how long it is, really.
There it is,
as long as it passes through it, okay? And then we'll put one over here. Let's see the second one over. Okay, now you can do the same thing on the other side, passing this way, if you want.
Okay.
You can do, for instance, on this side, we can do something similar. We'll move the second one over and we'll do a little box right here. You get the idea how easy it is. So we're just going to do another box.
And
now,
it doesn't matter how long they are because that original bounding box is going to cut it. Yeah.
How high it is above the center is how big your tab's going to be. Okay, so we're going to put one there. Okay, so now we have more solids in the part. Not only your mesh, but we have these solids. So let's go ahead and regenerate this. So you see that it's flagged red.
Oh yeah, okay.
So let's regenerate it.
And you don't even have to go back and do all that again. It just automatically regenerates. Crazy.
Yep. You'll see that
and
it
you
automatically
just clicked on the red dot and it did it. Okay.
Yep. And it automatically saw that there was more material there. And let's go ahead and do a simulation. And you can do a pause and go all the way to the end. Okay, so you see the tabs here?
Yeah, they're still there.
Yep.
Cool.
So you got a tab at each at two on each side. Okay, and you can obviously control. You know, when you create your solid box, you can offset if you wanted exactly a certain distance away from the center line or whatever. Okay, so there's our roughing operation. And we've got tabs in each of the corners. So let's go ahead and do a finishing operation. So let's go ahead and do a parallel finishing. And do you know what size tool you would like to use?
I don't. I haven't. If we need to order more tools, you give me your best recommendation for that.
Okay.
So and we'll get it.
You can see that the rectangle from the previous operation was automatically selected for this one. Okay. So in parallel finishing, it's going to follow your solids or mesh.
What exactly is meant by parallel finishing?
Okay. If you look at the little picture here, the tool path follows the part in a parallel plane, okay? So it's just going to go back and forth, okay, at a certain step over, and the tool is going to be on your part, okay?
Cool.
So, and the reason that you wouldn't need a containment rectangle if you wasn't using these tabs, because it would go all the way out. If you didn't select something, it would go all the way out. So we're using this to contain it for the finishing as well. So for a tool, now to get into those smaller areas, you're probably going to want to have either a small ball mill or maybe a tapered mill. Can you accept some draft on these squares, or do you want them square?
We would like them square, but we've also told the client like the design might have to be modified based on what we can do.
Yep. So, well, the only thing that you're going to see is you're going to see a fillet radius in this corner, okay? As the tool goes down and rolls over this radius, and this is a flat area, this is a vertical, so you're going to see a fillet there. So that will be depending on the diameter of your tool. So let's go ahead and create a tool.
The smaller we go.
Yeah, the smaller you go, and you can step this down. Okay, so what you can do, you can leave stock and then do another one with a smaller tool.
Yeah. Okay. Cool.
For now, let's go ahead and use 1/8 of an inch, just for practical purposes. Let's change that.
An 1/8 inch ball. Is it
ball mill?
Ball mill.
Ball mill. Sorry about that.
Cool.
So we got an 1/8 inch ball mill, and we probably don't need it to be that high. It's 3/4, so let's make this 1.25, and we can make that say 1.5. And the total length really only needs to be about 2 inches.
Yeah.
Okay, so we got a little bit stronger tool there to do
our. Is the flute length the same as like the cutting edge length?
Yes, that's the area of the tool that's actually doing the cutting.
That can cut. Yeah. Got it.
So let's go ahead and we'll call this ball mill 0.125 diameter, and we'll save this. And we'll select that, and we'll use the same feeds and speeds, same clearance. The cut parameters, we'll leave it set to 1/1000. That's the default tolerance. Now, if you wanted to, you can leave stock and then come back, or you can have it set stock to 0. For instance, we could, now since the stock is the exact width of your part, leaving a stock will actually, you won't cut any on the top. These tops won't be cut. It'll just be down in these deeper areas where you're going to see a tolerance. Okay, if you want to do it that way, we can add like a 0.20 tolerance, say.
Yeah. Okay.
Go up down in here, and we have a cut direction. The 0 angle is along the X, so it'll go this way. And you can control that if you want it to go the other way or on an angle, or however you want to do that.
Okay.
Okay, so for the Z containment, we want to also contain it to -1.5, okay? And for the step down, we'll go ahead and leave that. We'll do we can do an entry and exit, a linear or radial, okay? And let's go ahead and do a linear for now and see how that looks. And we might want to, okay, let's set this length to 0.02. Okay, and the angle to say 10 degrees. Or if you prefer a radial, we can just put in a radius of 0. Now this is the entry motion, not the cutting.
Right, whatever you think is better.
So we'll just put this in there and see how it looks.
Okay.
And then for the exit, we'll do a radial. Okay. And then we'll fit arcs. These will be arc motions where it can fit arcs.
Okay.
And there's no sorting. We don't need to do any sorting since it's all one piece. Let's go ahead and generate that. Okay.
Wow.
So one thing you did see in here, you see the red motions, the retract motions. Since there's no material, it dropped. In other words, it dropped off of the surface into an open area. Okay.
Yeah.
Now, if
Right.
you prefer not to have the retracts, what you can do is you can put a planar surface in there, like in the middle. For instance, if you put a surface plane, and let's see if it'll grab this midpoint of that. It's not going to find a midpoint. So let's do this. Let's create a surface from, since there's nothing to pick from, it's a mesh.
Yeah.
I wanted to pick a midpoint, but you can't pick a midpoint on a mesh since it's a mesh geometry. It's not a curved geometry. So what we're going to do is we're just going to pick this. Okay. And then we're going to put it over to here. So you see there's a surface there on the top. So now what we're going to do is we're going to offset that surface. Oh, excuse me. Let me escape out of that and just select the surface first. Okay. Okay. Okay, so let's hold on a second. I think that's a curve offset. Give me just 1 second.
Yeah, no worries.
Do a surface offset. We'll go ahead and select the surface. Okay. And we're going to set the distance to 7.5. Okay. We'll set that to a negative 7.5. Okay, so what you see here is we don't need this one anymore. We'll go ahead and hide that on another layer.
Okay.
Okay, and we'll just turn that layer off. Okay, so what I'm getting at here is if you don't want all the retracts, the program is going to see.
What do you mean by retract?
You see these red areas? The tool is going over it, and then it's going back up to the clearance plane, and then moving over and coming back down. If you don't want all those ups and downs, you can put a surface in there, and it's going to see that surface. Okay.
Okay.
So let's go ahead and do a regenerate the roughing. It's really not going to have any effect on the roughing, since the tool is not going down that deep anyway. But on the finish, you'll see.
So it'll just go down that curve, go across, and go back up.
All the surface.
Yeah. Okay.
And then, you got any questions so far about anything we're doing?
Not really. I'm just I'm very inexperienced at Rhino, but I'm following. I got what you're doing so far, I think.
Okay. Now one thing you see that it's going in this direction. Okay. So it left. It's rolling over this edge, and you may see some material here. What you can do is you can just make a copy of this and paste it, and then open it. And then we can change the direction to 90 and generate it, which you're going to have another pass at 90 at right angles to it.
The other direction.
Yeah, in the other direction. Okay.
Cool.
So now let's go ahead and do a quick simulation of these. Well, let's stop that. We want to simulate the horizontal roughing first.
Yeah.
And then we'll do the first parallel finishing. And as you can see,
cool.
It's just going along it. And again, you're going to you're going to have this cusping going around there.
Mm-hmm.
That's
Right.
why we did it in both directions.
Yeah.
Because the other finishing will get rid of the cusping in these areas. As you can see, there's not as much cusping in this direction going
Yeah.
this way. So you can just adjust those to the tool, based on the tool diameter, there's your offsets, what you're seeing on the part on the machine, whether you want it tighter or whether the finish is sufficient. So let's go
Right.
ahead and pause this and go to the end. Probably should have used a larger offset. It would have been a little bit faster for the demo, but.
Oh, that's. And then I could always go back with like a smaller
Yep.
ball mill and get that even tighter.
Yep.
Cool.
Now, in the standing configuration, it's when you go back and do another smaller ball mill with the finishing, it's going to go over the whole surface. It's not going to be just
right.
It's not going to be just a re-roughing. That's in a higher configuration of the product.
Yeah.
But you can just run it again with a smaller tool, and it'll get even more material off.
Right. But that looks great. I mean, I think they'd be happy with that even. Cool.
Any other questions while this is calculating?
Nope, I don't think so. I mean, so how did you set up that original perimeter again?
Which one?
The what did you call it? The original like outline box.
Oh, okay. Okay.
The bound.
I'll show you that. I'll show you that in just a second. You're talking about the stock or the inner?
Well, you set the stock and then you set like the.
Yeah, we drew just a square rectangle on the top of the part.
Okay, just a rectangle. Do you have to designate that as the boundary, or it just knows?
Yeah, you select that when you create your operation. If you recall, we selected.
Right. I remember. Okay. Yeah.
That's your containment area. And I apologize for the time, but I should have put a larger step over. But as you can see, there's a lot of areas to calculate. So it's going to take a little bit, maybe another 30, 45 seconds.
Okay.
That's how easy it is in RhinoCAM.
That's crazy.
Now, once you have this set up the way you want, you can go ahead and right-click on the setup and just post these out and create the G code. And
that was my next question. How do you create the code?
Since everything is basically symmetrical. Now these tabs may not be exactly symmetrical, so you may see some little bit of offsetting, but when you go in and you draw these, if you put them in the exact distances on each side, and then all you got to do is flip it over and run the program again.
Run it again. Cool. I guess another question is, so in Cabinet Vision, because we have like an 8 carousel tool on our machine, and so we say like the 1/2-inch diameter compression bit is in tool number 1. This tool is in tool number 2. How does it know? Is that all in the post processor?
No.
Or how does it know
if you edit your tool in the tool parameters, you can tell it what tool number it is.
Oh, okay. Cool.
So we have the ball mill set to tool number 2, and we have the flat mill tool number 1.
Perfect.
So as long as those have to correspond to your carousel, and the program automatically, if you run all these together, the G code will have the tool change in there. It'll have the tool number, which one to use. And
once I enter those tools for this project, are those saved in your tool catalog or?
Yep.
Okay.
What you can do is you can, they're saved in the drawing automatically, okay? And then you can save them to a tool library.
Cool.
Okay. We'll just call this. My tool library. Okay. Well, let's see. Try that again.
Oh, you have to select it.
Well, I think that message is an error because I know that I know their tools are in there, but I'll load it again on another part. But basically, all you got to do now is just flip it over, and you can tell the program where the tools are. In other words, which cutting, where do you want to go? What tool library do you want to use? So you just pick that as your tool library, and it's always going to load that every time you create a new drawing. Those tools are already going to be there for you to use, and then you can save them back to the library. Now, what we'll do is let's just save this for a second. We'll save that to top. Okay. Now, for instance, if you create a new part, let's just say we have a new dummy part, say, you see that the tools are already loaded.
Mm-hmm. Yeah.
Okay?
Cool.
And
Perfect.
to go back and let's go back and open that one part again. Since it's symmetrical, let's go back. Go back into that part. If, for example, this wasn't so symmetrical, okay, you can put some alignments in there. In other words, you're going to need to know where to put your holes for, to mount this, okay? But you really, depending on your geometry, you need to have the stock to be symmetrical with the part and the part centered, so that you, in this particular part, you basically, all you got to do is flip it over.
Yeah, when you flip it, it'll be exactly lined up.
Yeah.
Okay.
And if what I was going to say a moment ago, if the part was different on one side than the other, then you would need to go ahead and flip the part. In other words, you save the part as the top, and then you go in and you reorient the part. Say you can flip it over, okay? And you may, if it's a little bit different on that side or whatnot, or depending on the geometry, you may need to move it a little bit. It just depends on what's going on with the geometry itself. In this particular case, it's real simple. You don't have to do anything because you just flip it over and run the program again.
Yeah. Cool. That's so easy.
Now, you want to go ahead and see how easy it is to post?
Yes.
That may not be your post, but let's go ahead and you just click OK to that, and it's going to create the post file, and it'll display it here in Notepad in a second. It should.
There we go.
There we go. Let me bring it over here.
Cool.
So there's your G code for the roughing operation.
Okay.
And you see here tool number 1. So if you have an automatic tool changer, it's going to go and grab tool number 1. It's going to run that operation. Now, if you want to do the entire setup at one time, it's going to take a second.
Oh, so you can click on the different, you can post the,
you can post
just the horizontal roughing.
Yep, you can post just this one, or you can put whatever. You can pick the whole setup and post the whole setup, and you'll see that the T1 is being called. And let's do a edit find for T. And there's tool number 2. This is the parallel finishing. So it's gonna go and get tool number 2 and do the parallel finishing, and then you'll see when it's going to stay on tool number 2 for the third one. But we didn't, if you had a third one and a smaller tool and set it to another tool, it would go grab that one. Okay.
And then does where does it spit out the NC file to a folder?
Yes.
The same as all
you just tell it where to post it to.
Where to send it to. Okay.
Yeah, and over here, if you pick post over here, you'll see it. This is your post and save as dialog. You just tell it where to go.
Okay.
Okay.
Cool.
and
Okay.
all your post files will be there. Now, any other questions before we wrap it up?
What is the difference between free mill and mill?
Okay, in free mill, you're limited to one parallel finishing operation. Okay.
Okay.
And basically, it's a wizard. Okay, and you go through it and you tell it the size of your stock and the tool and everything, but it just has one operation. It'll just do a parallel
Whereas
finishing.
this one,
Yeah,
we've created the rough.
Yeah,
thing.
and
Okay.
it goes to the whole entire length of your part. So you need to clip these and make sure it's in the area that you want. So you don't really have any containment in the free mill. So that's where you got to be careful. You got to be exactly where your geometry stops, and your stock has to be exactly centered to make sure it doesn't cut all the way your stock. So it's a little more cumbersome, a lot more cumbersome, I should say.
Yes. And so this is mill. So I was looking, can I run mill on the trial version?
Yes. Mm-hmm.
I can. Okay, yes.
Yep.
And
if you,
so I was looking at price. Yeah, go ahead.
Kelly will handle all the pricing. If you want to, I can pass you over to someone in sales.
Looking, there was like different, there was like expert and this and that. Mm-hmm. I just didn't know what all the differences were, but this is great for us to do a test of this to see, you know, that it's what we want to do as possible.
Yeah, and I can give you some basic information about not for pricing, but as far as for features. If you go back into the mill, what we can do is let's go ahead and hold on a second. I'm turning off my license a second.
Okay.
Okay, so we have this saved to top. So let's go ahead and close Rhino and restart it here. You'll see it come up in demo mode. That's what you're seeing.
Yeah,
so
exactly.
So you go ahead and run it in standard. We'll run it in standard and pick the mill. Now you can run any of the configuration. If you notice that dialog where you pick run cam demo.
Uh-huh.
I'll show you that real quick. This dialog, you can run it in any configuration.
Okay.
But you can't, in the demo, you can't post and get G-code. And if you try to save, none of your operations will save, but you can run it and play around with it.
Yeah. Okay.
So let's go ahead. Cool. I was just going to run it in standard real quick and show you the. So basically, you got all of the 2-axis operations, and you have. We used horizontal roughing and parallel finishing, but you also have horizontal finishing that finishes in Z levels, like the side of the tool. Yeah. And you have the radial machining and the spiral machining. This is all in standard. And then you also get, in the standard, you get the high resolution simulation, the polygonal modeling simulation, which is what I showed you in the demo. So everything, as far as the simulation goes, everything you saw there is what's in the standard configuration.
Cool.
And then the libraries, you can save it to a library. That's all in the standard configuration. Okay.
Okay. Great. Well, this is so helpful. Thank you so much.
Would you mind holding on for just a second and allow my manager to talk to you and see how the demo went?
Yeah, for sure.
Okay.
Thank you so much.
Hold on just one second.
Okay.